Picture a foggy morning in the 1800s. Steam rises from factory chimneys. The air smells of coal and iron. And somewhere in this industrial landscape, there's a rumor that sounds absolutely impossible. There was one town in the 1800s that fixed industrial machines so well that factories started shipping them across entire countries just to be repaired there. Not to be built, not to be sold, just to be fixed. Think about that for a moment. In an era where transporting a steam engine across a single state could take weeks, factories were willing to ship their most valuable equipment hundreds of miles, just for repairs. Why? What was happening in this town that was so different from everywhere else? Here's the context you need to understand. Industrial machines in the 1800s broke down constantly. We're talking about massive steam engines, textile looms, hydraulic presses. These weren't like modern machines with standardized parts you could just order from a catalog. Every breakdown meant weeks of lost production. Every replacement part had to be custom made. And most repairs, they were temporary at best. Factory owners were desperate. Their entire operations depended on keeping these machines running, but most mechanics could only do patch jobs that would fail again in a few months. But this town was different. Some said the town's engineers could listen to a broken engine and instantly know every flaw. They claimed these mechanics had an almost supernatural understanding of how machines worked, that they could feel the problems through the vibrations, that they saw things other engineers missed. And here's the strangest part, they were right. So let's talk about this town. It wasn't a major industrial center. It wasn't particularly wealthy. It didn't have a famous engineering school or a prestigious technical academy. What it did have was craftsmen, lots of them. And here's the critical detail that everyone missed at the time. These people weren't trained as engineers. They were clockmakers, blacksmiths, woodworkers, instrument makers, gunsmiths. For generations, this town had been known for precision crafts. The kind of work where being off by a single millimeter could ruin an entire piece, where understanding how materials behave under stress wasn't something you learned from a textbook. It was something you felt in your hands after years of experience. When the Industrial Revolution came, these craftsmen saw something that factory-trained engineers didn't. They looked at a steam engine the same way they looked at a pocket watch. They saw it as a system where every component affected every other component, where balance mattered, where precision wasn't just about measurements, it was about understanding how forces moved through metal and wood. The factory engineers had been trained to think in terms of specifications and tolerances. They'd look at a blueprint, measure the parts, and if everything matched the design, they'd call it fixed. But the craftsmen, they didn't just repair machines. They didn't just replace broken parts with identical copies. They redesigned them. They'd take a factory-made gear and notice that while it met the specifications on paper, the metal had been stressed unevenly during manufacturing. They'd spot that a bearing surface had microscopic irregularities that would cause premature wear. They'd recognize that a support beam was flexing in ways the original designer never anticipated. And then they'd fix it, really fix it. This wasn't about having better tools or more advanced knowledge. This was about a completely different way of seeing mechanical systems, a way that came from generations of working with their hands, understanding materials, feeling how components interacted. The Industrial Revolution had separated design from execution. Engineers designed, laborers built, mechanics repaired. But these craftsmen still did all three at once, and that made all the difference. Let me walk you through exactly how they worked, because this is where it gets really interesting. When a factory engineer repaired a machine, they'd identify the broken component, manufacture or order a replacement, install it, and call it done. Maybe a day or two of work. When these craftsmen took on a repair, they'd completely disassemble the entire machine. Everything, even the parts that weren't broken. To a factory engineer, this seemed insane. Why take apart components that are working fine? You're just wasting time and risking breaking something else. But the craftsmen understood something crucial. In a mechanical system, nothing works in isolation. A gear that's technically functional might still be creating vibrations that stress a bearing 20 inches away. A shaft that spins smoothly might be microscopically misaligned in a way that will cause failure in 6 months. So they'd lay out every single component, and then they'd go through each one individually. Every gear was checked not just for damage, but for balance. They'd spin it, feel for wobble, listen for irregularities. If they found any, even if the gear looked perfect, they'd rebalance it. Sometimes by hand filing tiny amounts of metal, sometimes by adding small counterweights, whatever it took to make it spin true. Here's a detail that surprised even other mechanics of the era. They filed gears by hand to produce smoother rotation than factory-made components. Think about that. Factory gears were made with the best manufacturing techniques available, cut with precision machines, measured with calibrated instruments. And these craftsmen would take files and make them better. How? Because they weren't trying to match a specification. They were trying to match reality. They'd feel how the gear meshed with its neighbors. They'd notice that one tooth was catching slightly, creating a tiny pulse of friction 30 times per rotation. They'd identify that the metal was slightly harder on one side, creating uneven wear patterns. And they'd fix it, by hand, by feel, by experience. The same thing happened with materials. Factory parts were made from whatever material was specified in the design. If the blueprint said cast iron, you used cast iron. But the craftsmen would look at how the part actually functioned in the system. They'd see that a component was experiencing stress from an unexpected direction, or that temperature variations were causing expansion problems, or that the local humidity was affecting metal oxidation in ways the original designer never considered. So they'd change the material, use a different grade of steel, switch to bronze for a bearing surface, laminate wood instead of using a single piece, whatever solved the actual problem, not just the theoretical one. They tested everything too, not with precision instruments, those barely existed yet, but with craftsmen's tools. They'd check air temperature around the machine, monitor humidity levels, measure friction by hand, analyze vibration patterns by touch. Let me give you a real example, because this is where it gets almost unbelievable. A textile factory sent them a massive loom that had been breaking down every few weeks. The factory's own engineers had rebuilt it 3 times. Each time it would work for a while, then fail again. The craftsmen disassembled it completely. They spent 2 weeks going through every component. They rebalanced 47 gears. They replaced 6 shafts with ones made from a different steel alloy. They adjusted the tension system based on how the local humidity affected the wooden frame. They modified the drive train to account for vibrations they detected in the building's floor. When they shipped it back, the factory engineers were skeptical. It looked almost identical to how they'd built it. But when they started it up, it ran smoother than it ever had, quieter, more consistent. And here's the kicker, it produced 15% more output than it had when it was brand new. 15%, not from adding power, not from running it harder, just from making every component work in perfect harmony with every other component. The factory tested it for 6 months, expecting it to break down. It didn't. They ran it for 2 years. No major repairs needed. That's when other factories started paying attention. Word spread slowly at first. One factory owner would tell another at an industry conference. A traveling mechanic would see one of these rebuilt machines and notice how differently it performed. Gradually, more and more companies started sending their broken equipment to this small town. But here's what's fascinating. There was no advertising, no marketing, no salesmen traveling around promoting their services. The reputation spread entirely through results. And those results created something nobody anticipated. Factories started designing their production schedules around repair trips. They'd plan for a machine to be shipped to this town, anticipate it being gone for 3 to 6 weeks, and build their workflow around that timeline. Think about what that means. In an era where every day of downtime costs serious money, companies were willingly taking functional machines offline for weeks, shipping them hundreds of miles, paying for extensive repairs, and waiting for them to come back. Because they knew that machine would come back better than new, and it would keep running reliably for years. This created an interesting problem for the machine manufacturers. The companies that built industrial equipment started noticing a pattern. Machines that had been repaired in this town were outlasting their original specifications by a lot. At first, the manufacturers were curious. How were these craftsmen achieving such impressive results? Some sent their own engineers to observe, to learn the techniques. But they couldn't replicate it, because it wasn't really about techniques. It was about a fundamentally different approach to understanding mechanical systems. And then the manufacturers got angry. Because the craftsmen weren't just fixing design flaws, they were exposing them. A factory would send in a machine that kept breaking down, and it would come back modified in ways that made it clear the original design had problems. Problems the manufacturer had either missed or ignored. This raised an uncomfortable question. What if craftsmanship could outperform industrial mass production? The entire industrial revolution was built on a premise that standardized, factory-made products were superior to handmade goods. That precision manufacturing would always beat individual craftsmanship, that the future belonged to machines, not artisans. And here was this small town, with their traditional tools and old-world methods, taking the products of modern industry and making them better. It challenged everything the industrial age stood for. Some manufacturers tried to compete. They hired more engineers, developed better quality control, improved their manufacturing processes. But they were still thinking in terms of making better standard products. The craftsmen were thinking in terms of making each machine perfect for its specific situation. There's a bigger story here too, one that people at the time didn't fully appreciate. We tend to think of the Industrial Revolution as a simple narrative. Machines replaced craftsmen, mass production replaced individual creation, standardization replaced customization. But that's not quite right. What actually happened was more complex. The tension between craftsmanship and industry wasn't a simple opposition. It wasn't traditional versus modern, old versus new, past versus future. It was two different philosophies of how to make things. One prioritized efficiency, standardization, predictability. The other prioritized perfection, adaptation, understanding. Both had value. Both had their place. This town proved that the relationship between craft and industry didn't have to be adversarial. That maybe the best results came from combining industrial capability with craftsman's insight. That standardization and customization could coexist. But that's not the direction history went. So if this town was so successful, if their methods produced such remarkable results, why have most people never heard this story? Several reasons, and they're all connected. First, the craftsmen never patented anything. They never wrote down their methods in any systematic way. This wasn't because they were trying to keep secrets. It's because their knowledge didn't exist in a form that could be easily documented. How do you write down the ability to feel a microscopic imbalance in a gear? How do you patent the skill of understanding how metal behaves under stress through years of hands-on experience? How do you standardize the process of adapting each repair to the specific conditions of each machine and environment? You can't, not really. Their knowledge was embodied. It existed in their hands, their eyes, their intuition. It could be taught through apprenticeship, through working side by side for years. but it couldn't be packaged, sold, or scaled up. Second, the industrial world was moving towards standardization. In the early 1900s, there was a huge push to create universal standards for everything. Standard measurements, standard parts, standard procedures. This made sense for a lot of reasons. It made manufacturing more efficient. It made repairs easier. It allowed companies to operate at larger scales. But standardization has a dark side. It erases diversity. It eliminates approaches that don't fit the standard model, even if those approaches work better. By the 1920s, industrial standards had become so entrenched that there was no room for a small town doing custom repairs. Machines were designed to be serviced with standard parts, using standard procedures. The idea of completely disassembling and customizing each repair became not just inefficient, it became incompatible with how the entire system worked. Third, the craftsmen themselves were aging. The skills they had took decades to develop. You couldn't learn them from a textbook or a training course. You needed years of apprenticeship, thousands of hours of hands-on experience. And young people weren't entering those trades anymore. Why become a blacksmith or a clockmaker when you could get a better-paying job in a factory? Why spend 10 years learning to file gears by hand when machines could cut them in minutes? The knowledge wasn't lost all at once. It faded gradually as the old craftsmen retired and weren't replaced, as workshops closed, as the industrial world moved on. Imagine walking through that town now. You might find an abandoned repair workshop, rusty tools hanging on the walls, old blueprints and design drawings yellowed with age, wooden workbenches worn smooth by decades of use. All evidence of something remarkable, something that challenged the dominant narrative of progress, something that proved craftsmanship and industry didn't have to be enemies. But hardly anyone remembers. Here's the final irony, the real punchline to this whole story. They never intended to revolutionize anything. They weren't trying to prove a point about craft versus industry. They weren't making a political statement about the Industrial Revolution. They weren't attempting to preserve traditional ways of working against the tide of modernization. They just wanted machines to work right. That's it, that's the whole motivation. A machine would come in broken and they'd fix it properly. Not quickly, not cheaply, not standardized. Properly. And sometimes, that's enough to change the world. Even if the world forgets about it later. There's a lesson in this story that goes beyond machines and repairs. It's about what we lose when we prioritize efficiency over excellence, when we choose standardization over adaptation, when we forget that some kinds of knowledge can't be written down or packaged or scaled up. The Industrial Revolution brought us incredible things. Mass production lifted millions out of poverty. Standardization made technology accessible. Efficiency created abundance. But we also lost something. We lost the idea that each object could be perfect, that creation and repair could be an art, that understanding could come from hands and eyes and experience, not just from measurements and specifications. This town, these craftsmen, they represented a path not taken, a way of relating to technology that valued depth over speed, mastery over efficiency, adaptation over standardization. And for a brief moment in history, it worked. It worked so well that factories across entire countries relied on it. Then it faded away, not because it failed, but because the world chose a different path. Maybe that was inevitable. Maybe it was necessary. Maybe the benefits of standardization and mass production outweigh what was lost. But every now and then, it's worth remembering that there are other ways to make things, other approaches to solving problems, other forms of knowledge that don't fit neatly into our systems and standards. Because sometimes the most remarkable achievements are the ones nobody bothers to write down. The ones that exist only in the hands and minds of people who mastered their craft so thoroughly that it looked like magic. And sometimes, just wanting to do something right, really right, is revolutionary. Even if no one remembers it happened.